Right, for this video we're going to look at when we have a negative power. So if we have a to the power of negative m, a way to rewrite that with a positive power is by writing a to the power of m but moving it to the denominator. So 1 over a to the power of m. That would go the other way as well. If you had a to the power of m and you wanted to write it with a negative power, it would move to the denominator. So if it moves to the denominator, it just changes symbol, positive to negative. But this one is the one we're going to use more often. So let's have a look at some examples. So write the following with positive powers. So 3 to the power of negative 2. If we actually wanted to evaluate and find an answer for that, we'd first of all move that to the denominator. So 1 over 3 squared, change the negative 2 to positive. Then we can evaluate it because 3 squared is 9, so 1 over 9. Having a look at the next one, a to the power of negative 5. So we want to change that to positive, so we have to move it to the denominator and change the power to positive 5. That's u. 10 to the power of negative 3. So again, move it to the denominator, change the power from negative to positive. 10 cubed, so 10 times 10 times 10 is 1,000. So that becomes 1 over 1,000. Right, let's look at the next one. Now we've got a coefficient in front, so we've got 2. It's not in brackets, which means that the 2 isn't to the power of negative 3. It's just the b. So when we're moving it, we're only moving the one that is actually to the power to the denominator. The 2 has to stay on the top there, because it's not been put to the power of negative 3. 2 over b cubed. So we've moved it to the denominator and changed the power to positive. Right, we want to write this one with a positive power. Right now it's x to the power of negative 3. So this is us going back the other way. Here, we've started here and we're wanting to go back to the positive one. So that, if it's negative there, that becomes x cubed. Here, 2 over 3 t to the power negative 1. As you can see again, it's only the t that's the power negative 1. It's not in brackets, so it's not the 3 as well. So the 3 stays on the denominator and we bring t up to the numerator and change the power to positive 1, we can imagine is there, but we don't need to write that, over 3. Right, that's us starting to use some negative powers. This one says, rewrite the following with negative indices. So if you had this and you were trying to multiply it by something else and maybe you needed it to be a negative power before we could actually do the rest of it, it's quite useful to do this. So 1 over x cubed. With a negative power, that would be x to the power of negative 3. 1 over a to the power of 5, we would bring that up to the numerator, but we'd have to change the power to negative. And then 2 over c to the power of 8, 2 would stay on the numerator as well, c to the power of negative 8. Right, we're starting to go into some ones that combine other rules as well. So m cubed times m to the power of negative 5. If you're multiplying, then you're going to add the powers. So adding the powers, that becomes m to the power of 3 plus negative 5, which we know is the same as 3 minus 5, which take us to m to the power of negative 2. We know that if we want that power to be positive, we're then going to take it to the denominator, 1 over m squared. Right, next one we've got y cubed to the power of negative 4. So we've got a power to a power. So we're going to multiply those powers. That becomes y to the power of 3 times negative 4, which is negative 12. Then we want to write that with a positive power as our final answer. So we change that to 1 over y to the power of 12. Right, next we've got 3x to the power of 6 times 9x to the power of minus 6. So this one actually, so 3 times 9 is going to be 27. We're just using a negative power here, so x to the power of 6 plus negative 6. 27x to the power of 0, because 6 plus negative 6 is 0. X to the power of 0 is 1. 27 times 1, that actually just turns out to be 27. Right, now 4k cubed divided by 2k to the power of negative 2. So you divide the numbers first. So 4 divided by 2 is 2. K cubed divided by k to the power minus 2. If we're dividing, then we subtract the powers. So 3 minus negative 2. And so for this one, that ends up as 2k and you add them together, that becomes 2k to the power of 5. So just be careful when you're using negative powers and you're doing a division that you don't accidentally subtract 3 minus 2. That becomes 5. Okay, I'm going to do 2 more. This one here I've got a bracket, so we're going to multiply at the bracket. So x squared times x cubed. When you multiply them, you add the powers, so that becomes x to the power of 2 plus 3, which is 5. Then x times x to the power of negative 3. We're going to add the powers. 2 plus negative 3 is the same as negative 1. So just as our final answer, we don't want to leave that as a negative power. So we're just going to take it to the denominator and change it to positive. Final one we're going to do on this. That's a k, so 4k to the power of 7. Oh, sorry, there may be an h, but I've changed them all now. So 4k to the power of 7 times 3k to the power of negative 4 over 2k to the power of 4. So we're going to do the top bit first. So we're multiplying these together. 4 times 3 is 12. K to the power of 7 times k to the power of negative 4. You're going to add them together. 7 plus negative 4 is cubed, 3, over 2k to the power of 4. Left that the same, so 12 divided by 2 is 6. K to the power of 3 divided by k to the power of 4, you're going to subtract those powers. So 3 minus 4, you've got k to the power of negative 1. And then finally we're just going to move that k to the power of 1 to the denominator. The 6 isn't to the power of negative 1 because it's not inside a bracket. So the 6 stays at the top over k. We can imagine to the power of 1 is there. And that's you using some negative powers.